Okay. Good evening, everyone. Welcome to the session of seventh session. That's the live session that for the course of a statistic and biomedical engineering. And that my screen is visible. Can you just confirm for a while? My audio and screen both are okay, na? Okay, I'll go. I'll just check with that. My audio is audible. And the screen will be also there. Okay. Okay, welcome to the seventh session for the course of week seven, that is live session for the course of statistics and biomedical engineering. Um, um, my name is MD Ashad Raza, PMRF fellow and PhD scholar at the NIT Trichinopalli. So in the coming in the that last 6 week we have seen from the starting to went, and then we came to the that statistic that have the application in the biomedical engineer. So before the static of the statistic that we have seen that some fundamental concept and all, then we have seen the what is the component of the hypothesis and all that we have also seen, like central limit theorem, then hypothesis that then we have discussed what is that null hypothesis. Then we have discussed what is alternative hypothesis, like both are complementing each other. Like first we have to status quo, like we have to see okay whether there is any difference in all. So first we have to say no, there is no any difference, that's a status quo. Then we'll see what is the alternative hypothesis and all. Then we have checked the testing for the that small sample test, and then the large sample test and all. Then we have find out the corresponding p value also, like for like something the probability we have found out. After that, for the small sample test, we were having the t distribution that we have seen in the fifth week. And then we went to the type 1 error, type 2 error. Type 1 error is something that we were able to fail to what we can say reject the that's going to be null hypothesis that we have checked with the contingency table. And after that, we have checked for the type 2 error. So the type 1 error and type 2 error, type 2 error is something that we have missed the opportunity to fail the test. But the type 1 is something that we have failed, like we have missed it. And then after type 1 error is something like it's going to be inversely proportional to the type 2 error. Then we have checked the power of the test. Power of the test is something that they will give the power that much confidence you have that you are going to take any decision, or you have the power to take the decision. Either it's going to fail the test or fail the going to be null hypothesis, or we have to accept the that alternative hypothesis, like it's the actual cases we have. After that, we have checked with the chi-square distribution. Whenever the number of sample is going to be beyond of the 30 and all, that we have to check with that. Then if the number of sample is going to increase beyond of that limit, then it's going to tend to by the normal distributions and all. Then we have checked with the hypothesis test using the variance also. Variance is something like F test we have checked with that. Whenever we're going to see based upon the descriptive, it means mean, mode, and the median. But sometimes there will be some sort of outlier and all will be there. But if they will go into counterpart, but there will be deviation in the mean, mode, and mode will be that much not seen, or we can see we can't detect the changes much. So in that case, what will happen? The test might not give the best results. But we know that as a statistical and biomedical engineers, we have to think more of the clinical application or something. So we have to check the variance. Variance is nothing a error, or the difference is there. Variance not, I'll not say error, but it's something that they are going to say about the spread of the data set. So that's giving the error, like how much differences are coming. So that will give the more picture as compared to the what we have the description for the more, that's the mean and mode, and then it's going to other picture that we have. So anyway, the idea is to that we have to check the feasibility for the mean, not for the something that we're going to check for the variance and all. The idea will be whether there is any difference in the mean is there, or either it can be a effectiveness of the drug or effectiveness of any biomedical instrumentation, anything that can be there. But the thing is that the way we are going to approach it, it can be a different way. First one, it can go to the mean, or it can go to the mode, or we can go to the error. Error is something like we can go with the variances and all. So if you go with the chi-square test, like this again, it's a mean only, but it's for the higher, like it's going to positive skewed and all. And the F variance, like it's when we use the variance, when we use the variance and all, it will come to the what we something will say uh, like F test. So again, we have some constraint in the F test. Like when we're going to use the variance, why we can go with the only two group of the population. Okay, so that thing we'll discuss. Like why we are going to the ANOVA and all that we'll discuss. There is some sort of limitation that was there that we have to deal with that. We have to go move forward. As such, we have seen the T test. When we have checked with the chi-square test, then this is the variance like F test. After that, we have checked with two independent population like unpaired population, or one was the paired population. Paired population that we have seen in the last session, like whenever we have a something, the a sample will take a, we're going to take it some sort of diet A, and we are going to give the diet for some 6 month or 3 month or 4 month. Then we'll check before the diet and after the diet how it going to change. So it that will say paired test. And independent test, like we'll take, we have the some two three population, we'll take the sample and we are going to test it. So it will become independent that peer test and all. Okay. So then after, like then whenever we are going to say, we have seen observed that whenever we have till the test we have discussed like T test or either F test or the chi-square distributions, or we have checked with the pair T test, they were having, we were having the country that constraint or something that two group or two variable we can take it out. But in the reality, what will happen? We'll be having multiple cases will be there. Three group, four group, five group, and all will be there. To deal with that, we have the ANOVA. That will say ANOVA is like an extension of the F distributions actually. Extension of the that distribution. And it's going to be a like whenever we have the no more number of groups, if we have the two groups that we can go through a T test and all. Okay. So today that session agenda will be, it's going to be one way ANOVA. We'll see some sort of examples and all, and we'll see. So we'll see the ANOVA. What is the ANOVA actually? ANOVA stands for actually analysis of variance. Okay. Analysis of variance, that's going to be, if you're going to one way, so it's going to be like one way, then we can go with the multi-factor, it will become two-way ANOVA and all that we will discuss and all. Then we'll see what is the assumptions and all, then how we're going to solve the mean squared, and we'll check with the that square in it, and then we'll check some problems and all. That is the agenda for this week actually. Then after we'll see like something that in the coming sessions we'll see the some sort of random variable linear regression and then R square statistic and all. So can you tell like why we are going for the ANOVA? Just tell me like any idea if you have something idea about the ANOVA. Like we can just see like if it is, why we are going for the ANOVA and all. Whenever we have number of groups will be going to
This
more than, sorry.
this ANOVA will help us to prevent this prevent the typhoon error because there are multiple groups are there. So each group
Yeah, true. Actually,
will there
whenever
are
we'll be
like
yeah, whenever we'll be having more number of groups that we can do the repetitive test of T test and all we can do. But the thing is the chances of the error of the type 1 is going to increase. It means there is a chance that we are going to commit the type 1 error. To avoid those, we have now the ANOVA, like to compensate that one. So we will be having this type of test like ANOVA comes into the picture. So ANOVA is actually, it's an extension of the F test only. But the thing is that whenever the number of groups is going to be more, so we can check with that. So let's say we have the example like considering the quantitative that's going to be a variable, it's going to lead to the more explorative variable, so which fit this setting. Let's say I am saying academic department in sciences giving the lowest average grade. So who is the explanatory, or maybe something that's going to be department? Then what is the response variable? That is the student GPA. So which kind of promotional campaign that lead to the effective. Okay, so it's explanatory like that we're going to promotion type. Response variable will be the something daily store. So we have to check with the what type of variables, that variables we have checked that with the that's going to be random variable. And we have seen different types of variables are there, but will comes to the any group. In the group also we have to check which one like is giving which explanation. Let's say explanatory variable, it's something they are giving the explanation for what, that's going to response of the GPA. In the same case if we have the promotion. So it's a what type of promotion we are doing, what is the response we'll get, daily stored income. So it's something that we have, the one is the explanation, second one is going to response. Okay, so then after we have the how do the type of the career and marital status of a person related to the total cost of the annual claim say is likely to be the male or going to health insurance. Let's say we have the one couple is there. So how a person, if someone is going to be career and marital status, if it is going to be a bachelor and they have a good career, so they'll be given the health insurance, like their premium will be a bit low. If someone have the career and they are going to married, they can get it, but their premium will be that the minimum the premium will be bit of high compared to the. It's based upon the how much demand and supply. Let's say if they are going to have marital status, so let's say they have the husband, wife, then kids will be there. Then after, so here number of people will be more. Let's say we are going to cover for the whole family. So it's going to be like number of like things factor will be more. And if you talk about the career, in the career will be having like either it's going to be like let's say unemployed or self-employed or employed. In employed also will be having state government or central government or something. So number of variable, the factor is actually increasing. Okay, we have two groups only, but I think the factor will be like this only, but the number of factor that we are going to increase it. So in that case, we will be having like in that case, if we do the T test and all, so we have to consider either unemployed to the husband, like let's say one bachelor. Second group can come unemployed, then they have the husband, wife, and all. Then they have the which like what is the class of that employment and all. Then they'll check with the how many kids they have. Like kids will they'll check. Then they'll check the family member. So it means the factor number of factors is going to increase. So what will happen if you go with the what we can say traditional method to do the t testing and all? The idea is to we have to reduce the error. If we're going to not reduce the error, what we'll do? We'll be able like will not going to reject or like fail to reject the null hypothesis. Or what will happen? Like the things is that we'll not able to see any differences. Like it's something that we are going to fail to reject the null hypothesis. So in that case, hypothesis will be they are two always the same. First one with the population means of all groups under considered are equal. The idea is like that the name itself it's a analysis of variance. Don't think like we are going to check with the null hypothesis based upon the variance. It's going to be mean. Okay, the way we are going to calculate it's going to be ANOVA, it's going to variances, not the mean. So we have to think like we have to stick with the things like we have to check with the where is there any differences in the average mean or something or not. So, what will the alternate hypothesis? That population means are not going to be equal. That is the obvious thing we'll be having. Okay. Then after, we'll see. What is the example? We'll see a car, a magazine is going to wish to compare the some sort of. This is going to be an example. Compare the average petrol consumption of three similar model. Like say model one, model two, model 3 has available six vehicle of each model. So means in each model we have the six vehicle. Six vehicle. If We could have been one model, two model, like first population, second population. So then we could have gone with the t-test because the number of sample is 6 only. It's going to be a less than 30 only. So we can go with the t-test. But the thing is that if we are going to do the t-test here, model 1 to model 2 or model 1 to model 3, then model 2 to model 3, what will happen? We are going to we are going to something like we're going to chances of the type 1 error is going to be increased because that tree is going to take part and then it should come with the combinedly instead of going with the individually. Okay, so in that case, so it's better to go with the ANOVA testing instead of to go with the something like t test and all. So that's the idea to it's something we'll say motivation to go for the ANOVA and all. So whenever you are going to see any of the testing or all example, like in the biomedical, let's say we have the three types of drugs are there for a flu or fever. Drug one is something paracetamol. That is drug two, we have the dolo. Then drug three, something that is different we have. So now we want to check the efficacy of that particular drug for the particular flu. So in that case, we have the possibility we can go with the t-test. But the thing is that better to go with the something they are going to consider within the group or between the group so that we can get the better confidence to whether to check with the efficacy or better confidence in the position to whether we'll say what is the statistical interference for that particular test and all. So here we have the vehicle of each three model available. So there are three independent sample. Okay, so each of six size. So this example is extension of earlier t-test, what I told, t-test, something like this, which was two normal population because it's going to be lower like sample size and also we have that assumption that when we're going to take a sample from the any population that we are going to say it's going to be normal distributions at all. So means using independent sample, a pooled estimate of variance. So in this case, that is going to apply to the one way. So I think this example will be clear, is it?
Yes, sir.
Before starting, like I'm just trying to make the grounds like where we can apply and all. So if you have the doubt anytime, just ask me. Okay. Okay. So we'll see one more example. We have a this is example number two. A teacher is interested in a comparison of average percentage of the marks attained in an examination of five different subjects. So we have the five subjects. Let's say we are in the 12th class, or maybe we are in the first year of the BTech. So we'll be having some that will have them that's going to math, chemistry, physics, and then that some sort of core subject like basics of mechanical, if you're from mechanical, or basics of biomedical, something like this. So so it's going to five subject we have subject one, two, three, four, five, and eight student who all completed the each of examination available. So here the individual feature that same eight student each completed the five exams. So there are a five dependent sample each of size 8. Extension of the pair sample t-test is a two-way ANOVA. It means earlier we were having three different car model, but we have the each student is going to take part that particular five subject. It means it's a paired one. It's a dependent on each other. Okay. So if they're going to compare, it's something. So they have to do the dependent sample. So it means they will comes under the two-way ANOVA instead of going for the one-way ANOVA. So here we were having three model that was independent. That that is the one model is not going to affect directly in that case. But if you do the test and all, that will comes in the picture that going to be affect bit of much. So here, but what we have that eight student, all student is going to take this exam. It means this eight student is going to be like S1, S2, S3, S4, S5, 8. This 8 will take here also, 8 2 will take here also, 8 will take here also, 8 will take here also, 8 will take here also. It's not something that we are going to take. For S1 we have the 8 independent, S2 we have the 8 independent, 8, no, it's not like that. In that case, so we can apply the one way ANOVA. Okay, let's say if we have the S1, S2, S3, S4, S5. Let's say from school A, we took eight participants. School B, we took 8 participants. School 3, we take 8 participants. It's all independent participants. Independent participants. In that case, we can go with the one way ANOVA. But here, what we are saying that all eight students, they took all S1, S2, S3, S4, S5. So means it's going to be something like we have to go with the paired one. It's a dependent one. It means we can go for the two-way ANOVA. Is it clear?
Okay, sir.
Yeah. For today class, that we're going to we'll deal with the one-way ANOVA only. After one-way ANOVA, we're going to start with the some sort of linear regression or square regression, all that we'll see. Then we'll jump to the two-way ANOVA. Then we'll go with the design of experiment, then factorial experiment, design of experiments, and all that all we'll see. So that one-way ANOVA is actually analysis of the variance is used to test the claim three or more population means are equal or not. So that's the idea of analysis of variance. Okay. So the idea we are having like, okay, one more, I think they want to join. Let me add it. Okay, so the idea of one way like analysis of the variance is to test the claim three or more population means are equals. Okay, so here we'll be having like mu one is equal to mu two is equal to mu three, or n number of the groups will be there. But their assumption is something will be going to be like independent sample for the one way ANOVA. It should be a independent, and one more we have it's going to be normal distribution. Then we'll be having that each group has the equal variances also. That we'll see, but it's not going to be like then after it's a extension of two independent sample test. So actually the t-test actually we can apply for the two samples only. We can't go with beyond the two sample. Whenever the sample size got in case three sample, four sample, five sample, so we can go with the ANOVA. So then we have a but it will going to more it's going to discuss based upon the it's going to be a linear model, a statistical model that going to we are going to represent like a either way, either way it's a linear model. Okay, so in that case we have a fixed model, then we'll be having the random mixed model that we'll see. For the both cases we'll see some examples also, and all we'll see. Okay, so if you come an outcome, that outcome variable is something is going to represent the set of that is going to measure value. Outcome will be y will be the outcome ax plus b. So in that case, x is going to explain something that explanatory value. So a set of measure value result from an experiment or some other statistical process. And explanatory variable, on the other hand, that is going to useful to predicting the outcome value. Let's say I'm saying y is equal to ax plus b. So that our y is actually a outcome variable, and x is something it's going to be an explanatory value. Let's say I have a that is supposed to be slope, b we have the intercept. Okay, so let's say we know the some slope value, we know the some intercept value. So when the x value is going to change to the something, what will happen with the y? So this is y is going to become the outcome. Then x is actually it's going to dependent, like it's going to be a like explanatory value. Based upon the x, the y is going to change it out. Okay, so in the case of linear model, it's going to linear in the parameter, define the model. We can represent like yj is equal to beta naught plus beta 1 plus xij, beta 2 plus xij, something that e will be the error, epsilon will be the something error if we have something like this. So mostly in the linear cases that will be going to zero only, but sometimes that error can come. Okay, so this is the all about going to be a linear model. So analysis of the variant is something like we are going to set of data partitioned into the two or more component. So, and associated with the each component is a specific source of variations so that the analysis will become. So here, response variable is the variable you are going to comparing. The factor variable is going to categorical variable being used to define the group. Okay. Let's say I'm saying subject 1, subject 2, subject 3, subject 4, subject 5. Whether they're going to pass and fail, it's going to be outcome. How we have what we have done with the factor. Factor is something S1, S2, S3, S4, S5. Or let's say in the case of fertilizer, fertilizer A, fertilizer B, fertilizer C. So in that case, that will become your, what you can say, factor variable. If in the case of response variable, whether their main like effectiveness is going to be like play part of that or not. Okay. So the one way is because each value is classified exactly one way. It's something gender, race, political party, color, or something. So one way is something like will be having independent, but it will be having like let's say for the I took three model car and we check with the petrol car which are having the more consumption, which are having the less consumption. So that is going to tell about the independency that's going to be like that's going to be a for the what gen one means for the wait, the cursor model 1, model 2, model 3. So in that we were having six different car. In this having six different car. In this six we are having six different car. So it means each is representing their one particular population or sample. And we took one example S1, S2, S3, S4, S5. In that case, only one population, eight participant or eight student, they have taken all the subject. So in that case, interaction effect will come and it will become the paired detail. It's going to paired. It's not going to be a independent. In that case, we have to stick with the some two way. So that is the idea of one way and then two way. So if we talk about the what are the assumptions actually, so the first purpose to ANOVA actually to estimate the taste and about the population variances. Population variance, not the sample variance. To estimate the taste about the population mean. Actually, the main idea is something like we have to go with the mean. There is a differences are there or not. So null hypothesis that it's going to be mean or going to be equal. And alternative hypothesis is something at least one of the mean is going to be different. So there is no bar or limitations like something that we have to say all the samples or that group should have the different. It can be that it goes out of three. So that we have the null hypothesis. So it will say all the means are having equal mean. Let's say three group, four group, five group, and all. Alternate hypothesis is something at least one. Let's say I took some three fertilizer A, fertilizer B, fertilizer C. So in that, if at least one of the fertilizer having better accuracy or better performances, so we can say that's going to be alternate hypothesis. So it is not something like I told three we have mu1 and mu2, mu3. So that should be a, like mu1 is not equal to mu2 is not equal to mu3. It should not like this. It can be a mu1 is equal to mu2 but not equal to 3. Mu1 is equal to mu2 is not equal to, but it can become. So in that case, either of the case it became significant. So it means something it's going to be a claim about the like effectiveness of that. So we can say, okay, there is a we have the enough evidence, like we have the difference, but we can say differences are there. So what are the assumptions actually? The data should be randomly sampled. It should not like going to be categorized or something like this. We have to take, let's say we have the population one we have, and let's say I'm going to take some 10 sample, it should be random sample, not like categorized and all. Then variance of each sample are assumed to be equal. We have to take the sample, not the population. The here we have to check the estimate about the population variance. But if we talk about the sample, there should be variance should be something called equal. For then data should be normally distributed. It is something like we have the extension of the t-test only. So t-test having also assumptions of it's going to be normally distributed and all. Okay. So independence, normality, homogeneity of the variances. All group have the equal variance. So this is the about the some sort of basic assumptions actually. Okay. So in a two-mean t-test, we see like something that we are going to ANOVA you to compare multiple mean. If you see difference between the multiple sample mean is going to significant. So it's something like this. And difference between the ANOVA and t-test is something we are going to tell when two or more is going to being compared. Two group we have. So we can go with the t-test and all. Either it can be paired or it can be independent t-test and all. We can do it. But once it become more than two variables or groups, so that is going to be a limitations of the. In that case, we have to go for the ANOVA. ANOVA is actually necessary to protect the researcher from excessive risk of type 1 error. There is something I told in the starting also. Means in this situation where a study company more than two groups are going to meet. So whenever we are going to, because we can do the repetitive we can do the repetitive t-test, but the chances of the type 1 error is going to increase. In that case, we have to go with the some sort of ANOVA and all. What is the procedure? Procedure will be the always same. So first we have to check with the description of the data. Like we have to check with the data with normal that going to normally distributed or not, that going to randomly sampled or not, and we are going to read the assumptions also. Then we'll set the hypothesis like null hypothesis, then alternate hypothesis. Then we have to go with the test statistic. For the case of ANOVA, we have to go with the F test, like F statistic actually. F test, no, F test is actually for we have done for the two variances, like we have checked with the variances differences for the two sample. So that became the F test. Okay. Then we'll go with the decision rule. Once we'll calculate test statistics, so if calculated, we'll get some value. If tabulated at the degree of freedom and level of significance, then we'll compare it. If calculated is going to be if tabulated, so it's going to we are going to reject the null hypothesis. Okay. If calculated is going to be less than of if tabulated, what we'll do? We don't have enough evidence to reject the null hypothesis. We will not say a single word like we're going to accept the. Any statistician, they will not say we have accepted the null hypothesis. We'll say we don't have enough evidence. Actually, the similar meaning. But the thing is that we should term it in a different way. Then after we'll take the conclusion and then we are going to find out the p value and all. So this is the that is the procedure and all. So if you're going to in that, so when we'll set the hypothesis and test a statistic, so before that we have to find out some sort of variances, like that's going to be a mean squared between the group and then some all well see. So now we'll talk about the randomized experimental design. I told you that for the ANOVA, we have to the randomly sample. Let's say we have a availability of the subject is something 16 subjects is there. After that, we took some random number. Then we have categorized in a treatment A was done for like some sort of this 4 subjects. Then treatment B for the 4 subject, that was random sample. It was not like we took 1, 2, 3, 4 to the treatment A. Then the next 4 is going to with the B. Then the next 4 is going with the C. Or like that we didn't do it. We have done random number generation. We can in the some sort of MATLAB will say like we R and G and we have from 1 to 16 and we'll take just to select A needs some four sample and all. So we can do it. So they will going to that going to select the some sort of that's going to be a random number. Then we will categorize based upon the what it came out. Then so now it's a group one like treatment A, treatment B, treatment C, treatment D. Okay. So now we have the four groups are there. It means we have the more than two groups. So we can't go traditional method. We can't go with the T test, or maybe we can't go with the F test and all. So we have to stick with the what we can say ANOVA. Now the question is that which ANOVA that we should go, whether the samples are independent or not. So one way ANOVA, we took these four subjects are independent from the another four subject. That these four subjects are independent of the another four subject. It means independent. So we can go with the one way ANOVA testing and all. Okay. So this is the about how we are going to take a sample. Whenever we have a population. This one will say population. Then we have randomized. Then we have took the sample. So in that we have the some sort of assumption like data is going to be a normally distributed. Okay. So in that case, it's going to be like we'll go with the one way ANOVA test. So if you're going to like how we'll do it about this test setup. So first we have to go with the description of the data. We have to get the what is the xij and all we have seen here. Like we have the x11, x12, x13. Like it's going to group in going to like that one queue, x21, x31. We'll get the t1, then going to mean of that particular group. Then we'll get the total mean also. This is going to be total, then total mean also. That we'll see. Then after some sort of assumption we have to make it out. Sorry. Okay. So now that I told, like we are having a linear model to solve the ANOVA. Either it can be a two-way. Either we can fixed effect model, or we can go with the something like randomized. Random in the fixed effect model that the level of factor are predetermined. Like that factor is not going to be like change up and down. It's going to non-random. In that case, model structure will be like yij mu plus t tau I plus epsilon ij. Mu is going to overall mean effect of the treatment and then random error. Random error is the something like we have the normally distributed and all. Zero, sigma square, standard deviations and all. Now we'll see the random effect model that the level of factor are randomly selected from a larger population. Like we took some random sample. Now from that random sample also we have taken like something that we are going to interest in the variance among the level, not the level itself. In the fixed effect model, we have what we have to take, define the levels like treatment A, treatment B, treatment C, treatment D, and all. It's something that we have defined in. Now, we'll check with the variance among the level, like how much differences are there among the levels. Also, we can check it out. So, in that, that's going to be a random effect, and this is going to be random error. Here, mu will be the same. Here, effect of the effect will be there. So now we're going to compare factor level. It's going to predetermine, and for the random effect model, it's going to be a random sample from the populations and all. Inference, a specific level generalized to the population. And if we talk about the variance component, not estimated, we have to estimate it. And here it will going to be estimate itself. Hypothesis tested, difference in the mean. And here variance among the group. Okay. So if you see some sort of examples for fixed effect, actually, we have to comparing the teaching methods. Let's say we have the five faculties are there. They all five have the different slot or style of teaching. So we can go with the fixed effect because we know the things are already there. Then we have the drug type. Let's say fertilizer A, fertilizer B, fertilizer C. or maybe the marketing strategy. One example is there. So that all will comes under the fixed effect. What are the random effect? Quality control across the batches. So we don't know about the batch. Batch can be of like it's something like we can check it out, but we don't have actual batch. Like we don't know. We have taken some sample from the batches. We are checking it. We don't know the things like how it not defined actually. Machine performance. If we talk about the machine performance, machine have, let's say I'm taking the bike. In the bike, we have the petrol is the first, secondly the carburetor. What is the size of the engine? What are the things and all? It's a many factor. It's a random thing that is going to affect the performances and all. Then we have the one rhythmal effects. Rhythmal effects. Let's say we are in the Asia. So in that, like we'll be having some different factors will be there. If it's going to be Europe region, it's going to be it's going to be a different factor. It will comes into the picture. Let's say I'm going to take some example. Free fertilizer on a crop field. You're not just curious about that tree. You want to fertilizer type effect in that are going to yield in a general. So if you choose this tree specifically, so that will become the fixed effect model. If we check with the one three fertilizer only, in that case it's going to be like fixed effect. But if you randomly select in a that's going to larger pool, like if you're going to select some sort of, we have plenty number of samples and all are there. So in that case, in that case, we can go with the random effect model. So in this case, what will happen? Maybe if that by seeing the numbers and all, we can see that's going to be easy. But interpretation or the what is inference will be the bit of difficult. So we have to take some sort of assumption to deal with that. Okay. So now some sort of components of what you can say like computational parameter for ANOVA. So now we have first we have to calculate the total sum of the squares before we can do the partitioning, partition and all. First we have to obtain the total sum of the squares. The total sum of the square is the sum of the square that going to division from the individual observation from the mean of all observation taken together. So that formula will be something like this: SST Yij minus y bar whole square. Let's say I have y and A, B, C, D, E, F. Some samples are there. Some samples are there. So Y A bar, Y B bar, Y C bar, Y D bar. So this one will become y1 1, y1 2, y1 3. So here y1 1 minus, we'll take this all sample together. We'll calculate the mean all sample. That will tell you like that will solve some examples and all. So this is going to number. This is that y bar is going to all sample. Then we'll calculate the SST, some of the total square. Then after second one we have the SSB. SSB is something sum of the square or between the groups. Like let's say from A to B to C to D to E. So in that case, n whatever the number is there in that particular group. Let's say n a into y I. In that case, let's say in that group we have the y11, y21, y31, y41 will go. Then y bar like total of that. So this is the way of calculation for the SSB. Then we have the SSW within the group. So we have the formula SST is equal to SSB plus SSW. This is going to within, and this is going to be SSB. Then after we have to calculate the compute mean square. Mean square is something whatever mean square, whatever the square upon degree of freedom. Okay. So K is the number of group. Let's say I took here 5. So K is equal to 5. Let's say I have how many numbers are there? 5, 5, 5, 15s are there. So total number will become 15. Then after the MSW, like it's going to be SS by N minus K. It's again a degree of freedom. And if we talk about that, what is the total degree of freedom? It will become N minus 1. Okay. Then after compute the F statistic. So it's going to be MSB by MSW. Okay, I will solve one example actually. So, what will the ANOVA table? Actually, it's going to be between SSB. Degree of freedom will be the k minus 1 because I told you that we have the five groups. Five groups is going to minus 1. Then we have the within. It's going to be n minus k. Whatever the numbers we have, minus k, it will come within. Then total SST n minus 1. Then we can get the statistic. From the statistic, we can do the conclusion. I think till here it's clear. I'll solve one example actually. Till here it's clear, or shall I explain again?
Yes, sir. Yes, sir. We solved one problem.
Yeah, we'll solve one problem. So now we'll go with the testing the effect of tree fertilizer on a crop field. So can we go? Like, so starting to solve the problem. So first step will be group mean YA. It's going to be like 20 plus 20, 19 upon 3. It became how much? Can you please tell, like 20 plus 20, 42, 42 plus 19, 61. 61.3, so it will become 20.33. Is it? YB. We have 25 plus 27 plus 26 by 3. 25, 27, 52, 52 plus 26, 78, 78 by 3. How much? 26. Then YC. It had 23 plus 21 plus 22 by 3. 23, 21, 44, 44 plus 22, 66, 66 by 3, 22. So now we'll go to overall mean. Y bar. It's a this one. So we know this much, how much came? 61. This one 78. 66 by 9. How much? Please tell me. I think it will come 23.98. Is it? Just confirm it, please. So this was the step 1. So now step 2, we have to calculate sum of squares. So first one is that total sum of squares. What is the formula? Summation of Yij minus y bar whole square. I will take one page. Okay. So what will be there? First one, 20. Is it? Minus 23.89 whole square plus what is second value? 22 minus 23.89 plus 19 minus 23.89. Actually, we have to get y, its overall mean. So this is for one group. Second group, what we have? 25, 27, 26. 25 minus 23.89 plus 27, 26. 27 minus 23.89. 26 minus 23.89. Now we have the third group. 23, 21, 22. 23 minus 23.89 whole square plus 21 minus 23.89 whole square plus 22 minus 23.89 whole square. So what is the value came, or what will the value will come? Can you please tell? So next will be step is to get between group SSB. What is the formula? NiYi minus total whole square. So how many groups in a group A? How many are there? Three. It's a bar. Three into, if you go to the formula here, SSB. It's a YI bar actually. It means group mean. Okay. So group mean. What is the group mean actually? We have first one 20.33. 20.33 minus what is the group mean? 23.89. In second group, how many we have? Number 3. Second group, what is the average? 26. 26 minus 23.89 whole square. How many number we have in group third? 3 again. And what is the average? 22. 22 minus 3.89 whole square. Can you please tell what is the value of SSB? This is the SST. This is going to be SSB. What is the value actually? Please just do it. I will also do parallelly. I think 20 minus 23.89, it will come somewhere minus 2.11. Then I'll write some all value. It will come 76.86. It will come 58.22. So please just cross check after the session and all. This is the value will come. So now we will solve, go with the next step now. Because for the MF, we need MSB by MSW. So MSW, to get MSW, we need uh, SSW, like within sum of a squared of within. Okay. So that is the case. So first we'll find out the SSW. We know the formula for SST is equal to SSB plus SSW. So SSW will be become SST minus SSB. What we have? We have total of 76.86 minus 58.22. So it will become how much? 86 will become like something 6 minus 2 is equal to 4. Then 8 to 6. Then 16 8. So 18.64, that value we got. Till here it's clear, huh? Can you please just confirm it?
Yes,
Okay, I'll take one more page. So the next step will be to find out the degree of freedom. So we know what will be df1, it's going to be like n minus 1. How many groups we have? 3 minus 1, 2. Then within, how much will become df2? This will become n minus k. How many numbers we have? We have total numbers of, what we can say, 3. 3 into 3, 9 minus 6. So now we have to calculate the mean square. So first we calculate MSB. It will become SSB by between the degree of freedom. DFY1. SSB we have, how much we got from the last SSB we got 58.22 upon DF1 2. What is the value came? It will come 29.11. Then MSW. It will become SSW by DF2. What is the DF2? Like SSW we have 18.64. And DF2, how much we have? 6. So how much it will go? 3.11. Okay. So now we have calculated the mean square within the group. So now the idea is to go with the test statistic. Statistic is F is equal to MSB upon MSW. MSB, how much we have? 29.11, 3.11. How much the value will get? How much the value will get? Somewhere 9.36. It's a approximate. It's not the actual value. Okay, so once you calculated that our between the group, within the group, then total, then we went to the squared, then we calculated that degree of freedom, then we further went to the what we can say F statistic and all. So that the next idea will be to calculate the ANOVA table. Okay, so ANOVA table will make it. So first will be the source. Then will be the SS, sum of squares. Then we'll go degree of freedom. Then we'll go MS. MS means mean of sum of square. Then we have the F statistic or F value. Now further we can calculate the P value also. Whenever if you do the statistic test if from any of the software, it can be of either from that Python or any software you will do. So this table you will get it up. So what is the value of the between? Then we have the within. Then we have the total. Okay. So we'll see the table actually. We can see between, within, SSB, SSW, SST, K minus 1, N minus K, N minus 1 and all. And this is the like it was there. So what is the value of between actually? SS, not the MS. SSB we have 58.22. Then we have the within value, how much we have? 18.67. What is the total value? 76.91. Then what we have, the degree of freedom between the group, we have the 3 groups. So it will become n minus 1, 3 minus 1, it will become 2. Then we have the within. How many we have the total number? N minus k. No, it's k minus 1. N minus k, how much total number we have? 9 minus 3 is equal to 6. Then n minus 1, it will become the 8. Okay. Then ms value. Ms will be ss by degree of freedom of 1. It will become this much. How much we have? 29.11. Then it will become ssw by df2. How much we have? that 18.67 by 6.11. Then f is equal to msb by msw. How much came? 9.36. So this is the value of statistics. So now we can calculate the word f tabulated. F tabulated will be at degree of freedom of df1, df2 at level of significance. That level of significance can go 5% or 1% or anything. So this is f tabulated. This is calculated. No, no, this is calculated. Sorry, this is calculated. This is tabulated. So now based upon that, we can either going to reject the null hypothesis, or we don't have the enough evidence. I think till here it's clear. Huh? Can you please just tell? That is, yeah, tell me. Eh,
The last step alone,
the
once
last
can you
step.
explain?
Sorry, your voice is like
If
cutting.
statistic.
Oh, F
Yeah.
statistic, na?
Yes,
So,
sir, yes, sir.
F statistic, I'll show you. What we have done, we have calculated the SST with the formula, then SSB with the formula, then we got the SSW. After that, we have to divide by degree of freedom corresponding to the between and between the within. And F statistic, actually in the F test we have checked with the higher variance upon lower variance. Is it? When we were having two what do you say, group or sample in the last session, is it? But in the case of ANOVA, we have to go with the F is equal to MSB by MSW. MSB from where we got? SSB. It says sum square of error between the group. Okay. Then K is equal to number of group minus 1. Degree of freedom of the group. How many groups we have between the groups? It can be of 3 groups we have, but the degree of freedom will become n minus 1. Whatever the numbers, they're going to decrease, like we have to subtract 1. So that become K minus 1. Then MSW, once we calculate the SST, we can do the like SSW. Then if statistic will become between by within. I think it's will be clear. Is it?
Yes, sir.
We'll solve one more problem, and we'll try to figure it out. Same example, there is no much of difference. Only for practice, we'll do it. Okay. So can you please try it? I'll do it also parallelly, but just try. Step one, group mean. I will just brief here what we are supposed to go do there. What will calculate the SST? It will become sum of square of total with the formula of Yij minus total mean. Okay, that will become I is equal to 1 to n small n, because that particular group I is equal to j n. Okay, then after we have to calculate the SSB, means between the group, with the formula of sum of square of between, with the formula of summation of n. whatever the number in that group into mean of that group minus total mean. Okay. Then we know the formula of SST is equal to SSB plus SSW. So we'll calculate the SSW. It will become SST minus SSB. After that, we'll calculate the mean. Okay. Because the idea is to we have to check the mean differences between the samples and all. Okay. So MSB. Okay. Between the group, it will become mean. It will become SSB upon degree of freedom of 1. How come? Between the group, it will become degree of freedom of 1 will become K minus 1. K is equal to number of variables or group. Number of variable or group. Then MSW. SSW minus degree of freedom of 2. MSW is like within the group. This is the within group. Okay. So degree of freedom 2 will become how many? Because it's a within. Within means total number of sample minus 1. No, that the minus of number of groups. So N minus K. Okay. So now we calculate the MSB. Now we calculated the MSW. So F will be MSB by MSW. I think hopefully now it will be clear. So this will become our F statistical. I think now it's clear.
Yes, sir. Better,
Okay.
better understanding.
Okay. So we'll start doing this problem. Actually, a same example we'll do for better clarification. Okay. Please start doing. So I will take one page. I'll take this also. Okay. So first step is to group mean. Yx will become how much? 75, 80 plus 78 by 3. How much it will come? Can you please tell? Then y will become how much? 85 plus 88 plus 84 by 3. Just try to give the value. Actually, I don't have this question value actually. Then we have to calculate group mean. No, not group mean, overall mean. Summation of all 75, 80, 78 plus 85 plus 88 plus 84 plus 70, 72, 68 by 9. Just tell me the value. I think 75, 75, 7 at 15, 15, 7, 21. No, 778, 1522, and I think it will become 77.67. This will become 85.67. This will become 70, and overall will become 77.78. Okay. So what is the second step? To calculate the SST. What is the formula? Summation of Yij minus y bar whole square. So 75 minus 77.78 whole square, 80 minus 77.8 whole square, and then 78 minus 77.78 whole square plus 85 minus 77.78 whole square. Then we have 88 minus 77.78 whole square. Then 84 minus 77.8 whole square plus 70 minus 77.78 whole square plus 72 minus 77.78 whole square. Then we have 68 minus 77.78 whole square. If we calculate and all, that will get the value somewhere around, I will see 387.9. So this is the value of SST. Okay. So now we'll go. I'll take one more page. Maybe I'll take two more page. Will require. Okay. So now we'll calculate the SSB. SSB will be summation ni yi bar minus y bar whole square. So 377.76 minus 77.78 whole square plus 3. Second group mean was there 85.67 minus 77.78 whole square. Then third group also having 3 value. So 3, and how much we got? 70. So 70 minus 77.78. How much we got? SSB. If we calculate the SSB, we'll get 368.43. So now we know the SST is equal to SSB plus SSW. From here we can get SSW. How much will get? 387.09 minus 368.43. How much will get it? 18.66. So now degree of freedom. Okay. So degree of freedom will be something like we'll get between, it's a DF1 K minus 1. How many groups we have? 3 minus 1 is equal to 2. Okay. Then within DF2, it's a n minus k. How much we have? 9 minus 3 is equal to 6. Okay. So now that next step is to calculate mean squares. We'll go with the mean square. How much will come? MSB will become SSB by DF1. SSB, how much we have? SSB we have 368.43 by 2. How much it came? 184.22. MSW, how much we have? SSW by DF2, how much we have? 18.66 by 6, 3.11. So now we'll go with the F statistic. F value, MSB by MSW, 184.22 by 3.1. How much will come? 59.3. Now we'll go with the ANOVA table. First column will be source, then SS, then degree of freedom, MS is something like means that mean square, F statistic. This is the between. Then this one is having within, then total. How much we have between? 368.43, 18.66, 387 point something is there, like 09, 268, 184.22, 3.11, 59.23. I think it's clear till here. So this is the value of F calculated. Now F tabulated, we can get F at 2 degree of freedom, 6 degree of freedom at 0.05. We'll get the value, then we can calculate. I think one way ANOVA is clear, I think, hopefully. Is it? So there is one more term will come, confidence interval. How will get it? It will get the particular group Y, B or Y, I plus minus T of alpha by 2, T of alpha by 2 into degree of freedom into MSW by N. I'll take one more page. I'll clear way. So confidence interval, CI will become YI bar plus minus T at alpha by 2 at degree of freedom into MSW by N. Okay, mean square error actually. So N, whatever we have, N will be the number of group. So we can calculate the number of interval also we can calculate. Okay. So can we go to the next question or next topic? Shall we go?
Yes, sir.
Okay. So we have checked with that was the fixed model. Now we'll go with the that's going to be random effect model that we have to check. Like let's say going to larger population. The goal is not to compare between the specific level, but to how much variation exists across the population. So this we have discussed. Unlike fixed effects, which compares the mean, here random effect ANOVA answer like is there is significant variability among the groups are there or not. How much of the total variation is due to the group level differences are there. So assumptions, random sampling, groups are randomly selected from the larger population. That's a common for fixed effect also. Then we have the normality that should be there. Independence, observation should be independent also. Homogeneity of the variance within the group variance, constant group across the group. Okay. So I think we'll solve one problem actually. In that case, we have the formula till ANOVA table, it will be all same. Till ANOVA table, it's going to be same. Only thing we have to find out the within the group variance, between the group variance, that's all. Then intercorrelation coefficient. So shall I do or either it will be okay. That's going to be that's going to group variance will be the same what we calculated. Between the group variance, it will become ms between minus ms within. Let's say I have calculated msb minus msw by number group. So we will get the between group variance. Then interclass correlation will get from the here sigma square by sigma square by, like we'll just remove it this one. Okay. So this is the formula. So shall we do one problem or we'll go ahead with the problems, different problems?
Problem will solve.
Sorry.
One problem will solve, sir.
Okay. So we'll solve one problem. So the idea till ANOVA table will be the same. Whatever we have done, SSB, SSW, SST, alpha minus 1. So instead of alpha, we were having the k minus 1 and n minus k, n minus 1. Same formula it will comes. Only thing, the things will change here. Within the group variance will come ms within. Between the group variance, it will come this one. Interclass correlation. Based upon that, we are going to conclude. Okay. So this is the things we have to calculate. A textile company want to assess the variability in the fabric strength across 4 looms randomly selected from a large population. So we have randomly selected. It is the idea of ANOVA, but one more keyword they gave, a large population. Means we have to go through the random model. Each loom is tested 4 times, again 4 times, and the strength rating is something given. So now we have to calculate whether there differences are there or how much differences are coming on all. So can we start? We have to start from the step 1. What? Group mean. L1. It will come YL1. 45, 46, 46, 44 upon 4. How much the value will come? How much it will come?
Forty-five point five.
45.5. And YL2 will become 50, 52, 51, 49 by 4. It will come somewhere 50.5. And YL3 will become 43, 42, 44, 41 by 4. It will become how much? 42.5. YL4 will become, calculate how much will come, 47.5. I think clear, it's clear.
Yes, sir.
Now the next step will be to calculate the sum of a square. Is it?
Sir.
Yeah, we'll go sum of the squares now. We'll take one more page. I have to take more extra pages. I'll add this also. So what will be the next step to calculate the total sum of square? What will be the formula? SST summation of Yij minus Y bar. Before that, we have to calculate the group mean. No? What will the group mean? No, overall mean. Sorry. Summation of this, summation of this, summation of this, summation of this by 16. Please just do it and tell me. I'll check it sometime. Okay. It should come around, total will come 4, 4, 4, 16, 16, 5, 21, 26, 26, 31, 35, 49, 43, 47, 51, 50, 55, 59, somewhere 72, 8 by 16. How much will come? 45.5. So we got the value y bar. We got the value correspondingly also. Okay. So now the idea is to calculate for the, we'll calculate L1. For the L1, how much it will come? 45 minus 45.5. Is it? Then we have 47. Then we have 46. Then we have 49. No. So 44. How much it will come? If we calculate for 0.5, 0.5, 0.25, 2.5 to 2.25, then 46.5 to 0.25, 0.25, because once we calculate, so it will become, you know how, that the minus will become positive because it's a squared one. 5, it came 5. Now the L2, like second, like this is the learning method, loom method. What do we have? 50, 52, 50 minus 45.5 plus 52, 45.5 plus 51, 49. 51, 45.5, 49, 45.5. How much it will come total? Here 4.5, here 7.5, here 6.5, here 3.5. If you calculate, so it should come 105. Similarly, we'll go with the L3. So L3 group how much? 43, 42, 44, 41. 43, 42. So 43 minus 45.5. 42 minus 45.5 plus 44, 40, 41. 44, 45.5 plus 15%. If you calculate, it will come how much? Just check it. L4. What is the L4 value? 48, 47, 49, 46. 48, 47, 49. 48, 45.5 plus 45.5 plus 49 minus 45.5 plus how much is there? 46. I have done separately, but we can do it like so. How much it will come? It will come 21. It will come 141. So what will the value? 5 plus 105 plus 41 plus 21. So if you calculate 110, okay, 15%. So 62. So 172. Is it clear here? Till here? Shall I go ahead?
Sir,
Yeah. Yeah. Any doubt is there? Tell me.
No doubt, sir.
Okay, I'll go. So now we'll go with the between the groups. SSB. What is the formula? Summation N I Y I minus Y bar whole square. This is battery 15%. Okay. So how many numbers we have? Four. Is it? And how many? What are the first mean group? Can you just tell what was that first mean group? 45.5. 45.5. Overall group 55.5. It will become okay. We'll go ahead with that. Then again we have four. What was the second group mean was there? 450.5. Again, what was the 42.5? 47. 42.5. What is the average value actually? 45.5. Battery 15%. So 0, it become 5, 5 into 5, 25, 25 into 400. 42.5, 45.5 will become how much? 9. 9 into 4, 36. 2 to 4, 4, 4, 16. How much will come? 152. I think it's clear. Now we can go with the SSW. How much we calculate? SST minus SSB. 172 minus 152 become 52. So now degree of freedom BF n minus 1, 4 minus 1, 3, BF2 n minus k 16 minus 4 12. Just 1 minute. Okay. So what is the next step? We have to calculate the mean square. MSB will be MS SSB by degree of freedom of 1. What is the MS SSB? How much? 152. Degree of freedom 3. How much will come? 50.67. MSW. How much is there? SSW by degree of freedom of 2. How much it will come? 20 by 12. How much it will come? 1.61. F statistic will become MSB by MSW 50.67 by 1.67. How much it will come? 30.34. So this we got F calculated. Now we can get the F tabulated. How much? 4 minus 1, 3 and 12 add 0.05 will get some value from the table. We can take the decision. So now we have to check with the what is the estimate of next step is to estimate of variance component. What is the formula? We have to get the within here within group variance. It was sigma square. What was that? MSW. How much is that? 1.67. Then one more is there to calculate the between group variance. It will become MSB minus MSW upon number of group. How much is the 50.67 minus 1.67 by 4? How much it will come? 12.25. Okay. So this we got estimate of variance. What about the interclass correlation coefficient? It become rho. Rho formula, what we have seen? Sigma alpha square plus sigma alpha square by sigma alpha square. Sigma alpha square by sigma alpha square by sigma. How much is the 12.25 by 12.25 plus 1.25? How much it came? 0.88. It means higher correlation is there. I think it's clear now. It's clear, or do I need to explain again? Shall I, shall I go ahead?
Yes, sorry, go ahead.
Yeah. Okay. So I think that one, this is the simple question actually. They are saying this is going to be independent. Four detergent we have A, B, C, D. In that we have how much? One, two, three, four, five. Five sample, three sample. Then again five sample. Again we have four sample. So total N will become 5, 3, 8, 8, 5, 13, 4, 17. Then K will become 4. So N minus K will become 13. So the idea will be same again. We have to calculate the SST, SSB. Then we have to calculate the SSW barabar SST minus SSB. Then we'll go with the MSB is equal to SSB minus. So the degree of freedom will become K minus 1 is equal to 4. And DF2, this is will come 13. So DF1 MSW, MSSW upon it will come. Then we'll go with the F. It will become SS, no, MSB by MSW. We'll get some value. Then if they have asked to check for how much? They have asked to check for a level of significance 5%, whether differences are there or not. So we can calculate. So I think this is the simple question what we have done for the fixed module. It's a question of fixed effect. Is it? Or do you have any doubt in this? Like it's going to be a from random? No, no, because we have the four independent detergent. Is it?
Yes, sir.
So that's all for now, and we'll solve some question, like some theoretical question based upon the what we have discussed as of now. Shall we go? Shall we go?
Yes, sir.
Yeah. So just tell me now, what is the primary motivation for using one-way ANOVA that we have discussed in the starting itself? What is the primary motivation for using one-way ANOVA? Just tell me the answer. I'll wait.
Option.
Option:
Yes, sir.
to compare the variances. Don't get with the confused. When we talk about the population, for the population, it should be the mean itself. The idea is to compare the mean, not the variance. The variance is
Yes.
the method to go for the conclusion. Population comment on the mean of the population, not the variances of the population. Okay, because any hypothesis testing, the idea as such, we sorry,
Proceed.
yeah. So the answer will be C. So the compare the variances. I told whenever we have, if we talk about the sample, in that we are already saying the variances should be equal. But the thing is that when we're going to compare and all, it's going to be like mean of population. If you see the, I'll show the starting slide actually. Here, we can see here. Population means are equal. This is going to be null hypothesis. It's a mean, not the variance. Is it?
Yes, sir.
Yeah. Okay. To compare the mean of two population for this is not two population we can do for the what is ANOVA, but for that we have already t-test is there na. So motivation was to we were having the limitations to we can't do the three or four means, so that's why we came to ANOVA. So that two population is the limitations that the t-test was having. So that's why we moved to the ANOVA. So this is actually a t-test can be done. So this is not the motivation actually. To compare the variances, that's also not the motivation. Then to compare the means of three or more, that correctly, true only. To analyze the correlation between the two variables, no, that is the analysis that will do correlation analysis. Regression and all will check with that. Not for the that's going to be ANOVA. So for this we have the correct answer. C. I think it's going to be clear. Is it?
Yes, sir.
Okay. So that's the same thing I explained here also. So what is the following the key assumption of one-way ANOVA? Just tell me. Just read it and then tell. We have discussed in the starting itself. Sample should be whenever we have the three populations or four population, we are going to take the sample should be independent. It should not going to be a like depend on the each other for the one way. Let's see if the question will come for the two way. It
All the
can,
good.
yeah, it's going to be all of you. So if it is going to be a two-way ANOVA, so that independency will sometime will not be the, it's going to be hard rule. And the data should be normal, it should be because the ANOVA is just the extension of the t-test. Then variance of the population are equal. So all of the above is the assumption of what we can say we have the ANOVA. Okay, so I think it's clear. Independence of the observation, normality, then homogeneity of the variances. If we are going to with the some other way, so we can check with the barrel test and all that we'll see in the coming part of the lectures and all. Okay, just tell me about this one. In one way ANOVA, what does the F statistic represent? Tell me. In one way ANOVA, what does the F statistic? Can you tell me the formula of the F? MSB upon MSW. MSB stand for mean square between the group, and this is going to be a like mean square within the group. Is it? The ratio between the group variance to the group between the group variance to the within the group. It's correct. The ratio of the within group variance total no total variance no total variance is something M SS T will become SSB plus SSW. So it's not. But here we have the SB and B and then W only. So this can't be the answer. The ratio of total variance. No, total variance will not come into the picture. Only we have to check with the between two within only, not the total value. The sum of the square within the group. No, it's only one parameter. Actually, within the parameter, it's organ, not the sum of a square. It's going to mean. So the A option is a correct. A option that A option is the correct answer. Is it correct? because this question might will come in your assignment also sometime, or if you go for the exams and all, this type of tricky question can come. So just go through that what I'm explaining in the uh, every live session of the last like every that's going to last of the every live session. That 10 to 12 question is something I'm giving that's going to relevant to your assignment and end sem exam also. Not exactly, but end sem exam also. It's going to be similar type of question will be there. Okay. So I think it's clear now. So one way ANOVA is actually a MSB by MSW. It's a between the group variability, then within the group variability. Okay. Okay. So now we have the another question we have. What does the term fixed effect model in a one-way ANOVA refer to? I think this I have explained. Just please explain me. What will be the answer for that? What will be the answer for this? In the fixed effect model, the things, if we go to the assumptions or the definition, in the fixed effect model, that's something that we have to predefine or something that is are already fixed or chosen by the experimenter. Is it?
Yes, sir, that's correct answer.
So
I feel.
the B will be the correct answer. A model where the factor level are randomly selected. No, it's actually for the second model. Random effect model, not the fixed effect. So this can't be the answer for the fixed. A model that assume equal variances across the group. This is the assumptions, not the fixed effect model. That is not going to interpret about the this assumptions. Okay. So don't think like it's going to, but it's a something fixed effect model. It's going to term related to the fixed and something the level we have fixed it out. This assumption should be there. This is going to be assumption, not the term that is explaining the fixed effect model. So don't try to get confused. No, no. This will be the answer because that should be that the thing we have to assume it. No, this is the assumption, not the fixed term is going to show. Okay, this is the things that are going to explain with the term. So this is true for that particular process, but not explaining the fixed effect. A model does not include the interaction between the factor. Just this is something irrelevant regarding to the fixed effect model. How come? Fixed effect is something that is going to be fixed, chosen, and include the interaction. Interaction will comes into the picture when we have the dependent model and all will be there. This is part of two-way ANOVA. So in the context of fixed effect model, we don't have interaction effects and all. Okay. I think I'll be clear about this. Huh? So in way, one way and another with the fixed effect, the group are not randomly sampled from the population percentage level. Instead, they are a specific label deliberately chosen by the researcher. Okay. If you're going to compare effect of three specific fertilizer or crop yield, those three fertilizer are going to be fixed. In contrast, random effect would be assuming factor level themselves are randomly drawn from a larger population. So option B will be the correct option. Shall I go ahead? Next question.
Yes, sir.
Then we have the which of the following is true about the confidence interval for the main differences in one way ANOVA. Okay, something that I explained, but not too much. Just try to answer. How come it's going to help you out? It is always symmetric. How we can't say na? Not always.
D is the answer.
Okay. So that the idea is that why come? it can't be the always symmetric. Let's say I took one example. In one group, we were having detergent A 5, B was 3, C was 4, D was again 5. So in that case, it's not going to be symmetric. If the number is 4, 4, 4, it may be. So this is not always true. So this can't be the answer. Then it depends upon the mean square error and the sample size. Yes, confidence interval we have seen y bar plus minus t at alpha by 2 and degree of freedom into ms w by n. So n is the sample size. Then this is the mean square error. So this will be the correct answer. Is it? This is something that I spoke about into the lecture. It is you test used for the interaction between no. Confidence interval not something like this. It's again I'm saying this is going to be two-way ANOVA. It will come into the picture in the later part of that. So this is not going to relate it to the one way. It assumes the non-normality. No, it's going to violate the one way ANOVA. This is not it. This context is not explaining the confidence interval. So for this question, we have the answer of B. Am I clear?
Yes, sir.
This is something that I explained similar way. Xi minus xj, T alpha by 2, ms. If we have the different samples that we can go through that. It's something that similar formula is there. Okay. Now, in the context of one-way ANOVA, how is total sum of a square partition and what does it represent? Just read it. Try to understand what will be the answer of that. We have calculated the SST also. SST was SSB plus SSW. It means total variability. Is it? It's going to represent between the group SSB, then within the square. Is it? So it's going to be correct option. Is it? Now we'll check for the other also. SST is the only sum of square due to the error. No, it's a total. Tell me. It's a variability, not the error. SST is partition into the interaction and residual sum square. No, this is not the not it is in the context of SST. For one way ANOVA. Again, the terms are there. If it is going to be two-way ANOVA, so this picture will comes into the picture. This thing will comes into the picture actually. SST represent the total variance by the factor level. No, it's explained for all, between and within and all. That the okay. It's not only the factor level. It's going to be like error also plus error. I think this is clear now. This can't be the answer. This can't be the answer. This can't be. Is it clear? That shall I go ahead?
Yes, sir.
So this is the same thing I explained also. Next, consider a random effect model in one way ANOVA. What is the primary focus of this model compared to the fixed effect model? Just tell me. Earlier we have seen for the fixed model, what is the purpose for the random effect model and how can we compare for the fixed effect model? If we start random effect model, something we have to take from the large population and it's going to be a like variance for random effects and all. Estimating the individual group means no, it is the this is reflecting Fixed effect. Okay. Estimating the variance component associated with the random effect. Yeah, because we are checking with the random effect of a larger population with the context of variance. Okay. Testing for the interaction between the factor. No, this is going to be a for repeated measure ANOVA, not the random effect. And write the effect of time as a factor. It's going to be t-test. And this is not related to the something that random. I think this also clear. So factor level are specifically chosen by the researcher. It's something fixed effect model. Primary focus will be the group means. Random effect model for the one-way ANOVA. It's a random sample from a large population. It's the primary focus will be variance component, variability between the group, variability within the group. It's a due to the random effect, due to the residual error. So I think that B is the correct option. Is it clear?
Yes, sir.
Now we have next question. What is the impact of the increasing the number of group in a one-way ANOVA while keeping the total sample size is the constant? Again, some sort of tricky question. There is something that 50 are there. Initially A, B, C. Now what they're saying we have to, let's say, uh, it got from 3 to 5 group. So what will happen in that case? This number is fixed. 5 group came. So how can we explain? It decreases the power of unnoticed. It will decrease. It increases the between the group variability. No, because the number of group will becomes variability will become less. It become scarcity. Is it? It's not going to increase the variability. It increases the F statistic value. It not depends upon the number of groups and all. It depends upon the numbers, and it decreases the degree of freedom for the error terms. In terms, we can say it degree of freedom. It will decrease. We can say in one way ANOVA the sample size n, group k. So group have n minus k observation. Okay. So in that case, that the answer will be it decreases the ANOVA test and it decreases the degree of freedom. In what context? Like it will. So that too is the correct answer. I think it's clear now because whenever we are going to k minus 1, if number of degree of freedom is going to increase, let's say 3 was there, 1 is 2, then become 5 minus 1, it eventually it's increasing the degree of freedom. So this can't be the also option, is it? Is it clear or shall I explain again? We'll go elimination method. It increases between the group variability. Like the A, B, C number of people was more. Variability was something like it was there, but in when we number of goes so it's going to decrease the variability because we will knowing the specific and then if a statistic and nothing related to the number of sample size and all, it depends upon the MSB and MSW and it's going to actually increase the degree of freedom. So this will be the option. Shall I go ahead? I think three more questions are there, two more questions are there. Then we'll wind up. Is it?
Yes, sir.
What is the assumption are critical for the validity
Yes,
of the
sir.
F test in one way ANOVA? Assumptions are critical. Independence of the observation, it should be. Homogeneity, it should be. Normality of the distribution, it should
should
be.
be normal, should be
This can't be. It can be of another also. Number of sample is across
yes.
the group, it can change. So this all three is the answer. Okay. So this is how it explained through the explanation. This PPT I will actually uploading in that also. That you might have the mail and all also. You can get the access of this PPT also. Then we have the next question. Which of the following are the consequences of the unbalanced design in one-way ANOVA? What will happen when there is a unequal number of sample is there in the group? What will happen? One-way ANOVA, I'll just explain what happening. One-way ANOVA, it's a independent number of sample. What will happen if you're going to unbalanced design also? It's a independent. It's not going to be affect much. So that will not going to affect, is it? Increase the complexity in the interpreting the interaction effect. I told in the one way there will be no interaction effect will comes in the picture until unless we're going to do the repeated measure and all. This also not going to be a play part in the picture. Is it? What is the answer? A and D.
Option C.
Difficulty in maintaining the assumption of equivariances. It can come. Necessity for the using weighted mean in calculation also it will require. Okay. So unequal guys, unequal variances make ANOVA lesser robust and also we have to do the weighting. Now we have the what is the key characteristic of the F distributor used in a one-way ANOVA. What is the properties of F distribution used in the one-way ANOVA? It is always positive and right. That is right skewed that we have seen in the F distribution. It's always like this. Whenever it's going number of samples will increase, so it's going to tend toward normal distribution. It's a positively skewed. It will not going to be a this side. It's a variance. Variance will the variance or error. It's not going to become the negative. This option is a correct option. Okay. It depends on the degree of freedom for the both numerator and denominator. Yeah. Because F is equal to something MSB by MSW. MS the B is K minus 1. This one N minus K. So it depends upon the both degree of freedom. Na? So this also will be the correct answer. It becomes symmetric as the degree of freedom increases. No, it will become flat. So this can't be the answer. It uses the compare variances across the multiple group. Yeah, it's a actually F is the higher variance by lesser variance. It's a variance only because when we're doing the calculation SS, it's a summation of yi minus y. It's a variance only now. So A, B, C or A, B, D will be the correct option. I think it's clear now. Shall I go ahead?
Yes.
Last question we have. In which situation might assumption the one way will be the robot to the violation? When the sample size is large, it's good enough. It's going to increase the what? Power of the test. Then when the normality assumption is slightly violated, yeah. When the variance are slightly unequal, when the design is unbalanced but the sample size are proportional. We can see here one way assumption, independence of observation, normality, homogeneity of the variance across the group. But ANOVA is not robust to the many practical cases like when central limit theorem, homogeneity, unbalanced design. So that all four will be the answer. I think it's a clear. Okay. Okay. If any doubt is there, please ask. Thank you. Thank you for the joining today. Any doubt is there, please ask.
PPT is
Sorry.
uploaded very late only, sir. Can you upload little early? They're not getting the PPT, only video
Sorry. Can you
is
just type it? Your voice is like some sound is coming. External noise is coming.
She's asking for the PPT, sir.
Yeah, PPT is there on that spreadsheet.
Okay, sir.
So just check with the mail actually. Just check with the mail actually. They'll be sending the one spreadsheet link. There'll be that will be a link of that lecture, and then along with the PPT also. There is a drive link also there. Or I'll do one thing. I'll share it here only. I'll just stop the recording.